Hello all, welcome to the video lecture series for the subject database management system. Now I am going to explain you all about what is no SQL in relational database, right? So, and also we are going to see the non-relational database models as well, right? So now basically what is this no SQL? That means there is no structured query language. Is it possible to handle data, access data, store data without a structured query language, right? So basically here it is a type of database which stores the data using non-relational data model instead of traditional database. What is non-relational? It is actually opposite to the traditional database, right? Relational model in the sense every table which have an access relation of the other table, and also every key will be having an attributes, and every attributes will have a relational data model in a particular data structure, right? But here if there is no SQL, it is actually managing the relational, but here if there is no SQL, it is actually managing the non-relational data models, right? So we are going to see that with basic examples, right? So here we can see one important point, that is it is actually designed for effectively managing large volume of structured, semi-structured and unstructured data models, right? So it is going to handle all three, not only a specific model. So if you concentrate on SQL, it projects structured database, right? It is here, since it is a that is no SQL is a non-relational data model, it is also managed to do semi and unstructured data, right? So basically it optimizing the performance, right? No SQL is optimizing the performance by reducing the complex join operations here, right? So you might have seen there is so many joins in a relational data models, because if we need a table to be extended, then we are always looking for n number of joining a table, right? So here a particular table can have infinity number of joins, but here it is actually optimize the performance, and also it is totally reducing the complex joins, right? So now you can able to see a simple 4 different model here, right? So basically here this 4 different main types of no SQL database or the key value database, right? And then the documents databases, column family databases, right? And then we have a graph database, each designed to support different data storage and access requirement. That is a process. So here no SQL will have key and its value directly. There is no particular column to represent the key separately, value separately. And also here you can see the access requirement from graph to database, database to graph, right? And also it is a wide column. That means it is open for access, open for any kind of direct access. There is no SQL here, so it is open. So each design is here to support a data that is different storage and access requirement, right? Suppose I need to access from here, any kind of access is possible. That's a point, right? Any kind of access is possible, right? So here you can have this relational model here, any kind of access is possible. Document, graph, key values, wide column. So here the no SQL is actually open for any kind of this requirement, that is access requirement. So now I am going to take you one fine example how it is, that is no SQL is differentiated from traditional database. For example, right, an e-commerce application which stores product information where different products are having different attributes. So for example, let me take you to that part. Here you can able to see that, right? So one example, so this is a traditional SQL model, right? So here there is a product name. Assume that there is a supermarket, right? In the supermarket we have product name, color, size, RAM, storage and etc. So here 101 product ID have a t-shirt, The color is there, size is there, but there it doesn't have a particular attribute called RAM and storage. Whereas in product number 2, you can able to see the name of the product is smartphone. There is no color. If you can add, the color is also possible here. And size is null. Size is also possible. We can able to do that. And RAM, we have RAM, and storage we have. In order to differentiate this two, I intentionally made this color and size null here. Right? It is not like the phone doesn't have color, the phone doesn't have size. Absolutely it has. So my intentional is to drop here because to differentiate between a t-shirt which is necessary for this color and size, but here it is not option. I mean, here it is an optional, right? So here comes a traditional model. Imagine my field remains empty because all products share the same table. So now I am going to show you how this no data, SQL doc will have. So here it is. So I told you already, it is a wide column. Now you can see the key here, value here, the key here, the value here, the key here, the value here, and also directly from the database to graph, graph to database. I hope you understand. So here there is no SQL I should have to access the product ID, the name and color, the size. It has an open environment now. The access environment requirement here you can see, that is access requirement is very sequential, whereas here we have a separate particular SQL structured query in order to access any kind of attribute from this particular table, right? So here one more, this is 101 for example. Here you can see the 102. Again we have a key, this is a value, the key, the value, here also a key, a value, the key, a value. Got it? So here if we don't have the attribute which is not belongs to this particular product ID, it is not going to show null, because the key, if there is no key values, then the key is left empty here. Whereas in traditional model, you can able to see we need to intentionally do this particular thing if it is not suitable. I hope you understand the difference, right? So here, what if we use this no SQL doc? Right, that's a point. What if we use, see here the horizontal scalability is there because the data are distributed across multiple nodes, you can see here, and enabling the database to handle increasing workload. You can add n number of workload here, right? So here the distributed data storage is a very important point, which is actually stores and manage data across a cluster, right, of machines, improving the availability, supporting large scale of deployment, which is exactly not possible in this particular traditional model, right? So here also one more thing you can able to see, it has a multiple data models, right? For example, which supports, I already told you, it supports document, key and a value, right, column family, graph models, everything is possible over here. That's why this no SQL doc is called as a multiple data models. And also high availability, we cannot see there is null here, and also the it is actually a no SQL format, so there is no possibility of empty set return. We have a fault tolerance also here. It actually detects the node which is fails and continues serving requests using the replicated data and distributed storage. That's the point, right? So this is how this particular traditional and non-traditional database structures is actually differs, right? So I can able to point some popular NoSQL database, right? Say for example, MongoDB. We have MongoDB, which is very famous, and I hope you remember this Apache HBase, which are all very famous in this market. And then Amazon, we have one more thing, that is Amazon DynamoDB. I hope you remember this, which is most used in e-commerce, right? So I have taken the e-commerce structure here. And also most used, that is Azure Cosmos DB. I hope you remember this Cosmos DB. And also we have Google right? Which is very famous. You all might have known all this. Google Cloud Big Table, right? So here is some very famous, which is used application based and which is very popular in this industry and very popular with the user in the market, right? So what are all the applications by using this particular NoSQL docs, by using this popular database structures? What are the applications we have? See, we can use this content management system, right? For example, which is actually stores and retrieves articles, multimedia files, and metadata verifying the structures. And also we can, I'm talking about the application, right? So here I can mention this application here. And most used on this NoSQL docs are IoTs, for example, manage high frequency sensor and device data generated by connected systems. So you all know the trending format of IoTs, which is always used to generate what is it like n number of data, right? It may be a multimedia data, voice data, whatever it is, right? We have n number of IoT device which is connected in a human life nowadays. So it is actually generating n number of unstructured data, which is very easy for this NoSQL doc to manage, right? So that one best example I can give you. And one more thing I can able to catch up over here, that is which stores big data processing, maybe what is it like? It is the actual format we have, whatever the possibility of scenarios in this particular market. I am targeting all those things. So first of all, I said you IoTs. Now I am pointing on big data processing. What is that actually? It is actually, say, where there is a problem of data storage in unstructured or semi-structured or structured. So it is the big data processing actually focused towards stores and processing massive data sets, right? Where this NoSQL may be an optimized format for this. Whereas the traditional model requires n number of multiple access, right? But whereas in NoSQL data, this big data processing will be a very simple format for it, right? Massive data sets will be generated here from distributed application and also analytics platforms. As you all know how this big data processing works. So these two applications, right, which is very enormous requirement in the market, may have this NoSQL doc, which is very simple and also very optimized for this two application, which is very necessary nowadays in the market, right? So I hope I have given you some real-time applications and also how this NoSQL doc works. I hope you understand the lecture. Thank you so much.